before recently, intelligent design was illegal in schools. So you couldn't teach it at all. So it's actually a pretty big deal. States like Kansas have been teaching intelligent design for 30 years. So it's actually kind of dumb, but whatever.
For the record, I have no, objection to beliefs, or philosophies as long as it does not, harm other people. Yep. So so there's a place for everything. Okay, so science is science, and philosophy is philosophy. History is history. Yep.
Is it just like a certain grade?
I do not know. You have to look it up and find out the
So
details.
like say teaching that like all the way through, that would just get like repetitive.
Probably something they give to kids.
Yes, and we are wondering, why the United States is not ranked 1 anymore in science and engineering.
In everything.
In STEM, STEM stands for S T E M.
And we're gonna know the most about intelligent design though. They're gonna know the most about intelligent design though.
Yeah. Yes, but we can no longer design intelligently. Yes.
Good one.
We'll put it that way.
Really big opportunities.
So I cannot tell you how I look at this thing. I can only tell you that it's a news item, and you can read it and form your own opinion. All right. So getting back to this class, this class is definitely not about intelligent design. It's about hard stuff, man. Hard stuff.
Designing intelligently, like you said.
This is about verification. Okay, the design may be intelligent, but does it work? How do we verify that it works? Right. So that's what we are focusing on in this class. It's not so much the design itself. Actually, I have been criticized in past that I don't talk about the design of programming or programs enough in this class. The reason is, I want you guys to be familiarized with all the tools, the material first. It's kind of like building a house, okay? I don't want you to start to design a house and build a house until you know enough about the material. What is a 2x4? What is a 4x4? What can they do? How much can they support? What is a power drill? What is a circular saw? What is a miter saw? How do you use those things? I want you to be familiarized with all of those tools first and all the material before I say, okay, now go and design a doghouse. Okay, because otherwise, you can build something, but it may not work, and it's difficult to find out. Okay, how come my dog just died because the doghouse collapsed, right? That would not be a good thing. So that's why we are focusing on all of this stuff that we are just talking about. And finally, we are now on conditional statements. We are done with assignment statements, and now we are moving on to conditional statements. Hopefully, we'll have time today to move on to loops, because that's really an interesting topic. But we'll go through conditional statements first. Now, this one is truly interesting because we have seen this program or this particular pseudocode many times already. Okay, what does it do? If you just look at this source code here and tell me what exactly do you think it does? Yeah. If x is greater than y, then z gets the value of x. Else, z gets the value of y. So how do you think z relates to x and y after this code executes? Go ahead.
Number of the two.
Is the maximum of the two, okay? The maximum of the two. If you say the greater of the two, that means if they're equal, then it's undefined. But when you say it's the maximum, they can both be the maximum. Just nitpicking here. Okay, so we have done this many times, and we have thrown test cases at this code already, also several times. Okay, do you guys still remember that we kind of threw some test cases at it to make sure that it works? Okay, but no matter how many test cases we throw at this code, it is still not a guarantee that the next test case will be successful. Even though it looks like it should work for all cases, we don't really get a confirmation. So what we'll do in today's class is to see, well, one, how do we derive the pre and post conditions of a conditional statement? That's number one. And then two, we want to come back and say, okay, can we verify the result of this algorithm and make sure that it is correct? Can we prove that this algorithm will do what it claims to do? Okay, so those are the two things that we want to accomplish today. So the first thing first, how do we analyze this particular program? One way to look at this is, let me see if I can use a hand drawing program to illustrate it. It's not sometimes it's not that easy, but I'll give it a try. Okay, so I'm just going to use this as a electronic whiteboard, and here's my electronic pen. Okay, so we'll just draw the picture of a conditional statement, and then we'll say, at this point, what do we know? At this point, what do we know? At this point, what do we know? Okay, so we'll just go ahead and draw the shape of a conditional statement. It's not very even. Close enough. And then we have other side. There we go. So we have the basic shape of a conditional statement. We usually have a condition here. And I better change the color. Make sure it is clear. And not using dotted line, solid line. Stroke paint, we'll pick black here. Increase the color. There we go. All right. So this is the basic shape of a conditional statement. Excuse my drawing here. It's a little bit hard to draw with a mouse. I think I can ask the department to get me a tablet. All right, so this is a question, right? This is a condition. So I'll just say, instead of using a particular condition, I'll say this condition is just C, okay? C can be a condition like, x equals y, x is greater than y, y is less than 10, or whatever. It is something that evaluates to either true or false, okay? One more thing to do here is to label the paths. So we have to label the paths to either true or false. So, my convention is, true is on the left-hand side, and then false is on the right-hand side. Okay? But that simply is just my convention. It doesn't have to be that one. All right, so now we have the basic shape of a conditional statement. So let's go ahead and think, what do we know at this particular point? So I'm going to use a ellipse here, and just basically say, what do we know? What can I claim, at that point? And in addition to this, I'm going to write the actual pseudocode so we can refer to the pseudocode as we go through this. So we'll say in this pseudocode, let's change the font a little bit because it's too big. So line 1, okay, on line 1, it is the if statement. If C, then. On line 2, we have the then statement. So we'll just call this STMT1 for statement 1. On line 3, we have the else. On line 4, we have STMT2. And then on line 5, we have and if. Okay. So that's the pseudocode of this particular picture. What do we know at this point? It's before the entire conditional statement. Yep.
Anything that happened prior to that was true.
Okay.
It's possibly reachable.
Okay.
It should be.
Okay. But is there a particular way to denote that, whatever we know at that point? Is the precondition of line 1, pre-1, okay? It's just known as pre-1, okay? So in this case, I don't even care about what pre-1 really is. I'm just saying that, well, we know the name of that precondition. It simply has a name of pre-1. So we'll change the font back to a smaller one. Okay, so that's pre-1. So pre-1 is basically whatever we know before we get into the conditional statement. Is that okay? All right. Then we have to ask this question, okay? C is a condition, it's a question. It can only have one of two answers. It's either true or false. So the next question is, when we get to this point here, what can we say before statement 1 executes? Okay, there are two things actually. There are two things that we know for sure.
One is good. So
There's no post 1 because line 1 doesn't really do anything. So if you want to say something about post 1, it has to be the same as pre 1, right? So what do we know at this point where the blinky cursor is at? Okay, one thing we know for sure is whatever is true in pre 1 still has to be true.
Can you say it satisfies the condition?
Yes, whatever is true in pre 1 still has to be true where I'm at right now, because I don't have a chance to change anything yet. So the relationship of all the variables still has to be true at this point. Is that okay? But I know something else. I know one more thing at this point, because otherwise I would not be here. I would not have made a decision to go on the left-hand side in this case. So the fact that I'm on the left-hand side of this branch means what has to be true too. C also has to be true. Very good. So the expression is pre-1 and C, because C is already a condition. It's either true or false already. So I don't have to be redundant and say C equals true, even though that is not incorrect. It is not necessary. Are we doing okay so far with that statement? C is a condition already. It is either true or false already. So there's no need to compare that to the value of true. Okay. So for the same reason, I can now go back to the other branch before the statement executes, and I can claim something similar but a little bit different on this side. I can say pre-1 still has to be true, but you know what? I also can confirm that C has to be false, because otherwise I would not be going to the else branch. Is this all making sense so far?
What was C again? That's fine.
C is a condition. It's just a placeholder of a condition. So instead of mentioning a particular condition, I'm just saying, okay, it's a condition of some kind. So C can be expand into like this long, or it can be this short. It doesn't matter to me, because I'm just analyzing the structure of the code, regardless of what it actually has. Okay.
And that's an evaluation, though, right? C is an evaluation.
C is a condition.
Okay.
Yep, which is an expression that can either evaluate to true or false. All right, so now it's time to label these two boxes. One is STMT1 for statement 1, something that we do when the condition is true, and the other one is STMT2, which is something that we do when the statement is false. Okay. Next question. Next question is, what do we know, or how do we call this, and how do we call this? We'll handle the one on the left-hand side first. Okay, so how do we call this one? It's post, well, we can only say it's post 2, really. Because we don't know, because I didn't tell you what statement 1 is, so as a result, there's no way for me to tell you what post 2 is going to be. So post 2 is the only thing I can say is, well, it's the post condition of line 2, but it can be anything. And for the same reason, this side is known as post 4, because it is just whatever is the post condition of line 4. Okay. Which is not very, mysterious. The tricky part is, once the two paths merge, what can I conclude at that point? Post 2 or post 4, absolutely. Okay, so let me write it first, and then I'll go back and explain why that is the case. So post 2 or post 4 is the post condition